All right, okay. Welcome everyone. Oh, I am in the dark and I see everybody in the light, so that's nice. I can see everyone very clearly. Yeah, okay. All right, yes, so welcome. This is the first talk of the evening, and I'm also really looking forward to the rest of the talks from Anatoly and Eti. This talk is about MCP and Kafka, from intent to streaming MCP in practice with Kafka. Let's see. Yeah, a quick word about myself. So I'm Abhinav Sonkar. I'm a software architect at Actual. I've been with the company for over 8 years now, and yeah, I've been into lots of different roles, from product development to design to backend, Kubernetes, cloud, dealing with customers. It's been a really long and exciting journey. Yeah. My main area of interest is in backend systems, so I like to do building and operating backend systems since 2008. And while researching, I came across an interesting fact. When I first started, I was working with WebLogic. At that time, it was the version 7 in production. I think some of you may know about it. It was at that time owned by BEA Systems, and then it was in 2008 that Oracle bought BEA Systems and WebLogic. So I just found out that it was that year. All right. Okay. So today we are going to talk about MCP, of course, what it is. I'll give some historical context. Then I'll have a short demo of how we can use MCP with Kafka. A bit about security, because that's something that is definitely something to talk about when we talk about MCP. And then another demo about streaming applications, Kafka Streams apps with KSML. Okay, so let's get started. MCP, by the way, quick check. How many of you have heard of MCP, Model Context Protocol? Okay, everybody, all right. And how many of you have been using MCP or building MCP? Okay, few people. All right, good, good. So hopefully this would be then interesting for all of you, and we'll be excited to try it out after this. So Model Context Protocol, or MCP, is basically a way to have AI applications talk to any external system, right? That's all it is, really. So AI application, what do we mean by AI application here? So AI application is simply what you have idle in your laptop. So these days the most popular ones are Claude or Cursor or ChatGPT, all those kinds of things. And you have these external systems, databases, Slack notification system, Kafka, right? And MCP acts as a protocol, a standard that allows you to integrate these two things. Yeah? So at the heart of MCP is tool calling. Yeah? So what is tool calling? We will look into it in a bit more detail, because it's essential to understand tool calling, because that's really MCP. So let's set the stage. We have the large language model here on the right. We have the AI application. Yeah, imagine that to be Cloud Code. That's what I will use in the demo as well. Then we would have all the modern ones have MCP client, because they support MCP, right? And let's say you have built an MCP server, or you are using some MCP server, so that's also there. Initially, when you add an MCP server to your AI application, and I will show you, there is a initialization step, and that's the negotiation to discover the tools that are available in an MCP server. Because one of the primary things that MCP does is give you tools or capabilities to be able to do certain things, right? So for example, for a Kafka MCP server, you would be able to execute certain actions on Kafka, like creating Kafka topics or something, right? So you have the tools discovered. It's loaded in the context of the large language model. Now, as a user, you ask your first question: how many partitions does the orders topic have, right? That's your prompt. So this prompt goes to the LLM along with the list of tools that are available. And you're not limited to one MCP server, by the way. You can have multiple MCP servers, and all of them would then be integrated, and all the tools will be discovered and loaded in the context. So you have all that information sent to the model. Now the model cannot answer this question on its own, right? Because this is not in its training data. It's not a knowledge question, right? So the model says, okay, I will get the topic details, and then signals a stop reason tool use. which means, hey, to the AI app that I need to make use of a tool. I need to call a tool, right? And it also shares the information of which tool to call. In this case, get topic info, and the tool will have an input, in this case topic name, which is orders. So the LLM has correctly figured out that the name of the topic is orders and fills it in the input. So the tool call happens from the MCP client to the remote MCP server. This happens over HTTP because that's the modern choice of protocol transport. There was SSE as well, server-side events, but that's now deprecated. The MCP server receives the call, and it is designed to be able to talk to that external system, right? Kafka. So it makes its calls, returns the information. Let's see. So the tool result comes back, and some information comes back, right? So this could be, in this case, partitions 1, replication factor 3, and so on. Now the LLM has the information it needs to answer the question. So it formulates a text response, because LLM only talks text, right? Says the orders topic has one partition, signal stop reason, end turn, which means end of this round, end of this conversation. Okay. So that's what tool calling looks like, in a quick summary. One thing to notice here, that the LLM did not actually call or talk to the external system, Kafka in this case, right? This is often a misconception that happens because it's common to hear phrases like, LLM has gained capability to be able to talk to an external system or perform an action, do something, right? But that's marketing language. It's really technically not true. Technically, LLM cannot do any of these things. LLM can only respond back with text. Yeah. So it's your external system does not need to be opened up to LLM or anything else. Only the MCP server needs to access it. Okay. Then brief history. Just like LLMs, it's good to have some context around what we are looking at. I think a good starting point is June 2017, because it was around this time that the researchers at Google published a paper called Attention is All You Need, and they introduced the new neural network architecture called transformers. And this architecture is what makes the large language models possible today, right? So, a very milestone event, I think, in the AI community. Then 3 years later, OpenAI comes up with the GPT-3 model, right? And this proved the scale loss theory, right? Because GPT-3 was the first model that was trained on huge amounts of internet data. It had about 175 billion parameters. And so it was so big that it had a unique property. It could actually reply back in human text, in human-like text. So you can't really distinguish, is it the LLM saying or is it a human? They actually did a experiment as well with about 80 people, presented them with 2 sets of text, GPT generated text and human generated text, and yeah, only about 52% could guess it correctly. So yeah, it was really random guessing. Okay, then 2 years later, ChatGPT came out. Yeah, we all know that, right? It's very popular. A year later, function calling on tools API. So this is where MCP also starts coming in, because function calling tools API was the important feature that was needed. So LLMs can only reply in text, right? So, or tokens to be more technical. But then there are some special marker tokens that indicate that, okay, a tool call needs to happen, and that would then result in calls to external systems. They were made native as well a year later. So things like Cursor that you see today, Claude Code, they can read your file system, all of that happens via native tool use. And at this point, it became clear that, okay, external systems can be integrated. It's a need, it needs to be done. So if all AI apps and all systems need to be integrated point to point, that would not be efficient. So a protocol is needed. Okay, and that's where MCP comes in, right? And what's next? AGI? Well, not sure about that, but it's definitely going to be interesting. Okay, so governing Kafka with actual MCP server. So now we'll get into some Kafka specific details. Before I show the demo, a few things to set up. So yeah, we have a Kafka cluster, right? And you can create an MCP server that can talk directly to Kafka. That's possible. You can use the admin client API and do that, and that will be fine. But here at Actual, we have been building, working with Kafka, helping our customers with their enterprise problems. And in the course of this, we also built an API. And this API can actually, do a bunch of things. We'll go through that quickly. And it solves a lot of these enterprise problems for our customers. So some of them, governance, for example. So as the usage of Kafka grows, of course, you need to know what topics you have, what applications you have, and schemas. So having a catalog helps here. You need to know, okay, who owns all these resources, right? Because if you were to see a dangling Kafka ACL and need to delete it, you need to know who is going to get affected, right? Then multi-tenancy, multi-environment, you want to keep the cost of Kafka clusters low. Security, because by default, Kafka clusters are not secured, so you need to enforce that via policies and make sure that your topic, as a topic owner, you are not allowing anybody to access your topics, just who you want to via these request and approval workflows. And then developer productivity. So basically, in terms of what you see Kafka developers do, they're building producers, consumers, connectors, Kafka Streams app. They spend a lot of time doing this, right? So if you could take those connector configurations, take those streaming app topologies, and then just deploy it for them, they don't need to then focus on anything else except the business logic, right? So you have humans who need to talk to this API. So we have self-service UI. You have machines who also need to talk to the API. You have Terraform provider to fulfill all the GitOps hunger. And then somewhere between the humans and the machines are the LLMs who also now need to talk to the API. And so the MCP server. Okay, now time for some demo. I had originally planned to show you a video, but I'm feeling a bit brave. So let's make an attempt to show you live what I want to show you. And go easy on me. Yeah, video will act as the backup. Exactly. Yeah. Okay. Let's see. Yeah, everything is blue, so that's good. Okay, I have a terminal already. All right. So for the demo, what I will do is I have Claude Code in my laptop. Yeah. So that will act as my AI application. Since it's Claude Anthropic, the model will be Sonnet or Opus. In this case, I will use Sonnet 4.5. And the MCP server, Kafka, is running in Azure in some cloud. Okay, so let me check. Did I remove? Yeah, I removed it. Add transport. Yeah, so if you let me know if I need to zoom in a bit more. Okay, so so with this command, I'm trying to add the MCP server, which is running somewhere in remote, into Claude. So that will then initiate the first step, which is negotiation, initiation, discovery of tools. So Claude is added. Then Claude Code started. So usually with command like MCP, /MCP is common command for all these AI apps. And I see that actual is already connected because I had recently connected, but I will re-authenticate to show how the security thing happens. So security is enabled on this MCP server because for actual API, I need to have the user identity, because without that, I can't really allow creation of any resources. Otherwise, ownership is not clear. So this is a consent screen as part of a security. We will look into security in a bit more detail a little later. Okay, yeah, and here I'm logged in. And authentication successful. Yeah. So once you are connected, the negotiation has happened, and you can look at some tools, whatever is available in this MCP server. Create Kafka topic and a bunch of other things. Okay. So by the way, I'll quickly show you this as well. Yeah. So right now on the Kafka cluster, these two topics are available. and some random schema is available. Okay, just to confirm that things are working, I will ask a quick check question: which Kafka topics are available? Okay, so the prompt went to the model. The model said, I need tool call to happen for me to be able to answer the question. So let's use the search Kafka tools, search Kafka topics tool to find this information. And because I haven't given it any permission, it is asking me to confirm this. So I say yes, go ahead. And it says, yeah, found 2 streams matching the service. Yeah, smoke test Avro. And it gives a bunch of other information that it found from the response. Right? So this confirms that, yeah, the communication is working fine and it can discover the topics. Okay, now let's do some more interesting things. I have some prompts ready to, not type all these big things. So the first step, I would like to create an Avro schema called credit card transaction with a bunch of fields and their types. Yeah. Now in this case, I'm being very specific in what I want. So I'm exactly specifying what I want and what that schema should look like. Because if you don't do that, the model likes to really, add creativity on that and add bunch of things. But for this example, I want it to be very specific. So I give it all the details and I even say save it in a file. So it will locally also do that. So, and by the way, this step does not involve the MCP server because Avro schema is in its knowledge. So it can just do that, right, without needing any help. So just asking me to confirm it can create a new file, and it has now written that out. And then we can look at it here, credit card transactions. So this is purely the LLM, Sonnet in this case, creating this schema exactly as per, I hope, yeah, with a bunch of fields, enum as well. It has created it. Okay, looks good. Then, and from now we will start doing things with the MCP server. So the first step, I want to upload this schema into the database, so it's available under a certain version and owned by some team, because everything must be owned by a team. So now it will need a tool call, and so it will say, okay, shall I make a tool call, create schema to upload this with all the input parameters filled in that it has found. Let's confirm, and then schema is created successfully, gives me back some details. Let's check. Yeah, credit card transaction with the schema uploaded. So now the schema is available in the database. To be clear, this is not the schema registry, right? This is just the database, nothing on the Kafka or schema registry yet. Okay, then since we have a Avro schema available, let's make use of it and create a Kafka topic called credit card transactions with the key type as string, value type as the schema, and some more details in which environment and who should own it. And I'm also specifying how many partitions and the retention period, right? If you can choose to drop it, and then it will pick some defaults. So again, another tool is discovered, create Kafka topic, and it wants to call that. And then the Kafka topic, the tool execution happens and the topic is created. So now you should see, yeah, credit card transactions. And yeah, owned by the team, you have the schema that it is using, 1.0, and yeah, 30-day retention with 3 partitions. So at this point, we have a Kafka topic created in a Kafka cluster, and because it is using an Avro schema, a subject got registered in schema registry as well. Okay, then it would be nice to be able to produce some messages as per the schema, right? And so we do that, and this is another tool that is available that will produce messages, fill in all that information, and notice that it there is what it is using in the backend is something called KSML, which we'll come to in a little later. So what is important right now is to see that it is making some calls and getting it done. And yes, and say it's successfully started. So what has happened here, I'm going to just quickly go through it and then later on in detail. It tried to create a KSML definition, something that will make a producer application. Did not succeed at the first step, in the first attempt, because it just tried to do it on its own, and it does not know what is KSML. So hallucinated something, but the error message said, hey, you should use a MCP resource called KSML data generator, which is basically a bunch of text, knowledge to the model to tell it how to actually write these things. So it's with MCP resource, you basically are able to give extra knowledge which it does not have to do it things, right? So it does that. So in the second attempt, it makes the right thing, and then it succeeds. Okay, so let's check. So yeah, here you see that now we have the topic and an application registered, a producer application, which has been authorized to produce messages. And it says it's completed. Take a look. Yeah, some messages have been produced. Quickly check. And yeah. So we'll see that it has produced some messages. What is interesting is it did that as per the schema, first of all. Secondly, it generated some very useful, very contextually correct test messages, which is really awesome, because otherwise with these kinds of things, with test data, you usually get alphanumeric garbage kind of things, right? But here you, with the LLM itself, just put in some data that it thinks based on the fields, and it looks quite accurate, right? And so, yeah. So to quickly recap, we basically uploaded a schema, an Avro schema, created a topic with that schema, and produced some messages as per the schema, just by talking to the AI model. Okay, let's get back. So that's how some of the basic operations are done with this MCP and Kafka. Now I want to quickly take some time and talk about security, because when dealing with MCP servers, whether you are a user or whether you are developing MCP, you will be dealing with security, and this will be a nightmare to deal with, not just for building, but with your security teams to get this approved. And well, the reason for that is because it uses OAuth, right? Now, OAuth is something that we all know, right? We use it everywhere, right? I'm sure you are in your company using this. If you have Microsoft Entra or Google or Keycloak, OAuth is just ubiquitous and it's there everywhere. And MCP Spec also chose to use OAuth. So how does OAuth apply to the MCP systems? So back to this picture, the MCP server itself acts as the OAuth resource server. What that means is that the MCP server should be capable of accepting requests with bearer tokens, usually JWT, and then be able to validate it and grant access to the resources. The resources in this case would be the tools itself to have those tool calls. Then the OAuth client is the MCP client, right? So it's responsible for obtaining the tokens from an authorization server and making the calls. And finally, somewhere in the cloud, authorization server, right? Entra, GitHub, Google, Keycloak, whatever you're using. Okay, so what basically this means is this user there is authorizing this AI application to be able to access the MCP server as himself or herself and grant access to those tools. Okay, so OAuth it's OAuth, right? So it should not be that difficult. But here's the problem: the RFCs that are used in MCP spec, what the MCP spec says that you must adhere to, is actually a bunch of these RFCs, and there are more actually. I just took this from the screenshot on their website, but there are a lot more. And the problem is that most of the common enterprise authorization servers do not actually support many of these RFCs. Right? The most annoying one, the most challenging one would be Dynamic Client Registration Protocol, or DCR. So what is DCR basically? So to understand this in a very quick way, with OAuth, you know that usually the first step is you register your application with an authorization server, right? You register your client ID, you get a client secret back, you have a redirect URI which you register, and that's where you will get back the code and the tokens, correct? This establishes a trust. Your app is known to the authorization server and has been allowed to issue tokens. But this does not really apply to MCP because the clients are not known beforehand, right? As an example, we could all just open our laptops, start Claude or something, and try to connect to an MCP server. You all will be clients. But if I ask you all to first register with potentially a human approval to an authorization server, that's not really going to scale, right? So what MCP decided to do, the spec, is to use this DCR thing. It's not a new protocol, it's been there for quite some time, I think 2015 or something. So problem is, this is a very controversial protocol because it allows anyone to just register their client and then ask for tokens, and they will be able to get tokens. Security people don't like that. So the question is, how do we do it? Because Microsoft Entra does not support it. Google does not support it. Keycloak, I found out that it does, but yeah, even if it does, do you want to? Because you will have a pile up of clients that you need to clean up, right? So how to do this then? We looked at Spring AI as one of the options because here at Actual we love Spring and we like to build everything with Spring Boot where possible. But when we were doing this, it did not support it. It did not support DCR. But I also looked recently that the new version, Spring Security 7, has added DCR support, so it might have become possible. I haven't looked into it, need to check. So the other thing we looked at was, so we went outside Java and saw, okay, in the Python world there is FastMCP, a very popular library, open source, that a lot of people use to build MCP servers. And it's really cool because you don't have to deal with all the boilerplate of SDKs and get your first MCP server running very quickly. But for our purpose, it actually supports a bunch of different authentication patterns, including OAuth proxy, a way that allows us to use MCP without having DCR. So yeah, quickly how that looks like. So again, setting the stage here, we have the authorization server on the right, the blue, the API, that's the app that the MCP server is wrapping. In the middle, we have the MCP server powered by FastMCP with OAuth proxy enabled. So there's a client ID and secret configured, so it can obtain tokens with our authorization server, and then MCP client on the left. In this picture, there are actually two OAuth flows happening. One on the right, authorization server, the resource server is our API, and OAuth proxy acting as the OAuth client. So there will be OAuth dance happening between them. Then there is one on the left, where OAuth proxy becomes the authorization server, MCP server becomes the resource server, and OAuth client is the MCP client. So you can already see that the middle section is acting as everything, right? Resource server, authorization server, and the client. So you can see how it easily can get very complicated. So MCP client makes that DCR request. So basically say, hey, I'm a client, I need to register. Here's my redirect URL, please allow me to get tokens. OAuth proxy says, sure, go ahead. So get code, exchange the code with the tokens, your typical authorization code flow, right? And then you have some tokens. Our authorization server, the real authorization server in blue, has issued a token, the blue envelope. The OAuth proxy in the MCP server has issued another token, the red token, right? And the OAuth proxy is maintaining an internal mapping between the two tokens, the red and the blue. So now, when the tool call happens with the bearer token attached, OAuth proxy looks at that red token, says, yeah, it's valid, then looks up the corresponding blue token, replaces it, calls the API with that blue token, which will work because the blue token is meant for the API, and then returns back the response. Yeah. So this is how, it's a very tricky OAuth setup. Without having DCR support on your authorization server, you have your MCP server still working. And remember that the blue token and the red token carry the user identity, which is what you need, right, on the API. Oh, yeah, but wait. The story is not over yet. Just like a cool M. Night Shyamalan movie, there's a twist. Dynamic client registration is deprecated. Yeah. So in the latest spec that was released in November 2025, they deprecated DCR. So after all this work, yeah, it's time to say the DUI. They don't actually use the word deprecated, right? So because it's a spec, so they use terminologies. So something that was introduced in March with a should, so you should support DCR. By November 2025, it became you may support DCR, right? Which is effectively saying that it's deprecated. Some in the spec they also mentioned that they only included this because of backwards compatibility. So if this is deprecated, what are they recommending? So they are recommending a different thing now called OAuth client ID metadata documents, CIMD. I haven't had a time to look at it yet, and this is not a security talk, so don't want to go into that much of detail. But the takeaway here for security is that you have to deal with it. First of all, of course, it's not going to be easy at all. You need a library like FastMCP or maybe Spring AI. Probably it's now good, and you can still use DCR. So even though it's deprecated, it's still there. It's fine. And I also saw that FastMCP is now adding support for CIMD. So yeah, things will look good. Okay. Now to the last part of the talk, the Kafka Streams applications, right? We saw in the previous demo how you can do some basic operations with Kafka, but now, well, the interesting thing is you are of course building applications, right? And especially with Kafka, the Kafka Streams applications are quite interesting because they solve some interesting streaming challenges. There's a Kafka Streams library which is in Java, and if you're familiar with it, if you have used it, you know that you need to write a topology in Java and then package it and run it. But that's a lot of work. So what we thought is, what if we make a tool that can actually write things not in Java, right, but say in YAML, because everybody loves YAML, right? Yeah, and a little bit of Python as well. So this tool is called KSML. It's an open source project. You can check it out. What you can do basically is you can write your Kafka Streams topology in YAML format. And an example is here. So you can see in this pipeline we have a topic that we are reading from, and then pass all the messages through a filter which does some sort of filtering logic, and then it's written to the output topic. So a very simple filtering application that you just write like this, and in the actual platform you can deploy it as is, and then it will run it for you, so you don't have to worry about anything. So that would take care of your streaming needs. You have the producing option as well. So something that is not in Kafka Streams library, but with KSML, you have the data generator that can be used to produce messages, and that's what you saw in the first demo, right? So you can basically choose to either continuously produce messages or produce messages and then stop. Very useful for testing if you're building a consumer application. And finally, the last thing before I show the demo is MCP resources. So we talked about MCP tools, right? Tools are basically things that are doing something, performing an action, right? But that's not the only thing that is good for. Usually tools are the most important thing, of course, but there is also MCP resources, and that's the opposite. It is some read-only data. As I said, some knowledge, some information that the model may not have, and you want to give it to that. Okay. All right. So this one is I'm going to show in the video only because otherwise it would take too long. Okay. Screen. Okay. So some of the steps would be similar, and then we'll deploy a Kafka Streams app. So I'm adding the MCP server here, just like before, and I start it. Use Claude with dangerously skip permissions, and then it won't bother you every time asking, can I do this? Can I do that? Needs authentication. So yeah, you authenticate, you go back. So that whole security flow that I showed you with DCR and everything with OAuth proxy in the middle, all of that is happening, which allows you to then log in via Google, which otherwise would not be possible. And this gives you the Google identity that gets carried over. and then you can look at the tools. Yeah, basically in the same way. When this video was recorded a few months back, Sonnet 4 was the latest model. Now Sonnet 4.5 is there. Okay, so let's stop here and quickly I will read out. So what I'm trying to do here is to create a Kafka Streams use case. So again, same filtering application. Consider that we have a bus journeys topic that contains bus number as string key and a JSON value containing the details of the bus journey, like source and destination cities of Netherlands and the status. Please draft a KSML definition, that YAML thing, to read from this topic, filter the bus journeys that are delayed and produce it to another topic, right? Named bus journeys delayed. Do not create any topics yet because that's the next step. So all I'm asking now is give me a KSML definition, right? And remember, this model has no idea about, well, relatively no idea about what is KSML because it's a fairly new thing. It does not have it in its training data set. Yes, okay. Right. So first, it will look at the MCP resources because it in the context all the tools and resources are loaded. It sees there is a resource called KSML definition, which is relevant to this. So it will read that up and sort of get a crash course in what is KSML, how to write KSML definitions. So that then you see that it has created this KSML topology with the two topics, the filter function is delayed, which looks at the status of the value, and if it is delayed, it will match and then put it into the output topic. Yeah. So really useful to be able to use MCP resources in this way. And then we're asking, hey, create the topic, deploy this application, get necessary access to the topics. Notice the sentencing structure, get necessary access, because that is enough for the LLM to understand what it needs to get. By the way, Claude makes this to-do list, which I really like. You can see what all things it is going to do. So first, create all the topics. Yeah. And you can see that even if you don't provide all the necessary information, it's fine because it can fill it on its own or it will ask you. Then it will register that KSML definition towards the platform and get all the credentials and everything generated. Yeah. Because topics are not accessible by default, so you must have some credentials and authorizations. And then it now gets the relevant access, and it knows even with that just get necessary access that it needs to get consume access on the input topic and produce access on the target topic. So that's really great. And then start that application. Yeah. So we have the filtering pipeline set with the two topics and the application in the middle. So the next step, well, let's test it through, right, by producing some messages. So yeah, a quick check. We see all the KSML definition is here, correctly uploaded. Yeah, and yes, the app is running. Okay, so yeah, let's run some messages through this and see whether it works. Well, which it will work because yeah, it's a video. I know it works. So you can see that it will now read that MCP resource again to gain knowledge of how to write data generators, producers with KSML. So you're not limited to what the model knows. You can teach it, sort of like RAG, the regenerative augmentation thing. Sorry, what was that? I forget the full form again. But sort of like that, you can teach it on the fly what it needs to know. Okay, so the producer is registered, and yeah. Messages are produced. Then we can have a look at these messages. Yeah. So the bus number is the key, and the value is bunch of information about the journey. We only ask for source and destination and the status. But the model likes to, if you are not saying that only add these things, it will add a lot more, like driver and other things. And we said cities of Netherlands, so everything is Dutch. Okay, since the filtering application is already running, it should already filter some messages that are delayed journeys. 12 out of the 50, and all of these are the delayed messages, delayed bus journeys, right? So from scratch, you created 2 topics. You created a Kafka Streams filtering application, deployed it, ran some test messages through it, and we're able to confirm that it works. So this may not be for production, of course, but this is really powerful for prototyping, for figuring out you have a new use case you need to build. So, okay, let's try it out. Even though you may not be familiar with Kafka Streams, you may not be familiar with Kafka itself as much as you ideally should, it doesn't stop you from trying this out, get everything working, and then, of course, learning everything. And lastly, of course, yeah, I mean, we browse the messages in Kafka, in the UI, but you can even ask the question to that. So here I asked which bus journeys are delayed, and give me a summary in nice table format. And so model likes to do that and give us so Amsterdam is the most affected as the source city, Zaanstad as the destination city. So yeah, basically browsed all the messages and analyzed it and generated a report. Yeah, and finally stopped the application. So yeah, that's how Kafka Streams application can be dealt with. Yeah. Yes. Okay, so yeah, I'm curious, what do you think about it? And what else can we do with this? Just one last slide to wrap it up. Some of the links to the things that I talked about: MCP, the Spec documentation, the MCP server, KSML, FastMCP, really nice project. I recommend it. Even if you don't know Python, you can still go for it. The documentation is very good, and wipe code the first MCP server, right? It really is very good. Point it to the documentation, ask it to build a first MCP server with a tool, and it will do it for you. And yeah, I'm on Twitter. You can follow me there, and I usually also like to write some blogs on Medium. Great, thank you.